Hello, today we're going to do lesson 12.2, analyzing arithmetic sequences and series. An arithmetic sequence is when the difference of the consecutive terms is constant. In a few seconds I'll show you what I'm talking about. This constant difference is called the common difference, and it's denoted by D. So first, let's just talk about when we can recognize whether or not we have an arithmetic sequence. So if I take a look and I do 1 minus negative 4, I get a difference of 5. If I go and I do 6 minus 1, I get a difference of 5. And if I do 11 minus 6, I get a difference of 5. And lastly, 16 minus 11. So because all of the terms I was given have the same common difference, this is an arithmetic sequence. So I want you to take a minute to pause the video and try this next problem on your own. Now the order of which you subtract is important. You must do the bigger term minus the smaller term. So you must do, and I don't mean bigger, I mean if this is the first term, second term, third term. So you must do the second minus the first, the third minus the second, the fourth minus the third, and so on. Okay, welcome back. Now, it's very important that you memorize the rule for an arithmetic sequence. This is the rule for an arithmetic sequence. You are always going to plug in your A1 and you are going to plug in a D. So when we find our rule, we will have N in the formula. So the rule is the nth term of an arithmetic sequence with first term A sub 1 and a common difference of D is given by this equation. And like I said, very, very, very important to memorize it. So just a quick example. It says the nth term of an arithmetic sequence with a first term of 2, so notice 2 got plugged in for A sub 1, and a common difference of 3, so 3 got plugged in for D, is given by this equation. Now, what we will always do is we'll go ahead and distribute and add our like terms. So this is how I want to see your answer. Okay, now we're just going to get started. So what we're going to do is a whole bunch of different types of problems given certain components of the arithmetic sequence, and we are writing a rule for all of them. Okay, so here we go. The directions say, write the rule for the nth term of the sequence and find the next term. We're going to always write down a rule. This is what I like to do because we have to memorize it anyway. We're going to see what we have and see what we need to find. Now, in this sequence, do I have A sub 1? Yes, it's 4. Do I have a common difference? Well, I wasn't given a common difference, but I can find it. I can just subtract 2 of the terms. Remember, the higher term subtracted by the lower term, so 9 minus 4 is 5. So our D is 5. Plug those 2 in. So A sub n, we put 4 in for A sub 1. We put D, 5 in for D. We're going to distribute. We're going to go ahead and add up like terms. Here's my rule. Now it also says find the next term. Now we know we can just add 5 and get the next term, right? If I just take 19 plus 5, my next term would be 24. Or I see I have 1, 2, 3, 4 terms, so my next term is 5. So if I plug 5 in for n, I get 5 times 5, which is 25, plus a negative 1 is 24. So this is how I would write it. The fifth term is 24. Now, I want you to follow exactly what I did, and I want you to try this next. You try. So you're going to start with the A sub 1. You're going to find your common difference. Now look, even though the numbers are going down, you still need to do your second term minus your first term. It's okay if you get a negative number for D. Okay, so whatever you get here is going to be your D. Go ahead, plug those 2 in, and simplify it as I did, and find your next term. Okay, welcome back. This problem is a little bit trickier because now we're not given A sub 1. So we're going to have to do a little bit of work to find it. So again, I'm going to write my rule down. I like to have it for every type of problem that I do. This way, I can see what I have and I can see what I need to find. So this time you're given the D, but you're not given the A sub 1. However, you're given a certain term. You're given the 19th term to equal 48. So here's how we plug this in. This will go in for n. This will go in for A sub n. So what you're saying is the 19th term is 48. So watch how I plug it in. 48 goes here. We don't know A sub 1. We know n is the 19th term, and we know D. Okay, so what we're going to do is we're going to do 48 equals A sub 1. This is going to be 18 Then multiply 18 times 3, you get 54. Now we can go ahead and solve for our a sub 1 by subtracting 54 on both sides. When I do that, I get a sub 1 to equal -6. So now you have what you need. So now we're going to take our d, take our a sub 1, and plug it in just like we did in the previous problem. Not going to plug anything else in because I need to write my rule. We're going to leave our a sub n alone. We're going to leave our n alone. Go ahead and distribute. Go ahead, add up like terms, and this is our rule. Okay, I want you to follow exactly what I did on this you try. So this time, you're going to plug 27 in for n. You're going to plug 263 into a sub n, and obviously this goes in for d. You're going to solve for a sub 1, and then you're going to replug a sub 1 and d back in. Follow my work. Okay, this last type of problem when we're writing our rule for an arithmetic sequence is the trickiest. The reason it's our trickiest is because we're missing our a sub 1 and our d. So what does that mean? We're missing two variables. So what we're going to need to do in order to find our two variables is we're going to have to solve a system of equation. Now the good thing is this system is very easy to solve. So let's get started with plugging in. This goes in for n, this goes in for a sub n. We're going to do that. We're going to ignore this for right now. Okay, so go ahead and do that. So we have 21 equals a sub 1. 8 goes in for n. So I'm just going to write it as 8 minus 1. I'm going to write it as 7d. Okay? Now, I'm going to take this, I'm going to ignore the first part, and I'm going to plug 27 in for n and 97 in for a sub n. So I'm going to get 27 equals a sub 1 plus, this time our n is 27, so 27 minus 1 is 26, d. Okay, now, what I like to do is I like to make one of these. It doesn't matter which one. You're going to subtract the whole equation because when you do that, your a's are just going to cancel. So change, change, change. Go ahead and add them. And look, this isn't so bad. Negative 21 plus 27 is 6. The a sub 1's cancel. I get 19d here. So when I solve, oh, this should be, I'm sorry, this should be 97, not 27. So that's 76. I apologize, I wrote it wrong. This is 97. So I get d to equal 4. Okay, now I have one of the things I need, but I'm still missing a sub 1. So we're going to take this and we're going to pick an equation to plug it in for. It doesn't matter which one. I'll just plug it in for the bottom because I didn't make any sign changes to that one. So 97 equals a sub 1 plus 26 times 4. When you go ahead and do the algebra for this, you're going to solve and you get a sub 1 to be -7. Okay, now I have exactly what I need, back to the very first example that I did. So now I'm going to take my a sub 1 and take my d4 and plug them in again. So leave the a sub n alone, leave the n alone, and then you can go ahead and write your equation. We're going to distribute and add up your like terms, and this is what you should have as your final answer. Okay, now I want you to try the you try on your own. Let me help you out. When you plug it in, you're going to plug 10 in for n, and you're going to plug 148 in for a sub n. Then you're going to just leave it alone. Then we're going to go ahead and plug in 44 for n and 556 for a sub n. And then leave it alone. Take one of the equations, make all the terms, change the sign of all the terms of one equation, and then you'll get your d. Okay, follow my steps. Try this. You are going to see a problem like this on the test. Okay, moving on to the very last thing. An arithmetic series is an expression formed by adding the terms of an arithmetic sequence. So this is the same thing. You don't even need to know this because we're able to use our calculators. So we can go ahead and just calculate the sum of these by doing the shortcut, which I believe was alpha F2, and the number 2 was a summation. So go ahead, take a minute, try both of these, plug it into your calculator, just like we've been doing, and what you should realize is you will get 1,110 for this one, and 1,568 for this one. Okay, any questions, comments, or concerns? Go ahead, write them on the bottom of the paper, and I will see you tomorrow in class.